What has changed between Java 21 and 25? Let's find out.
Welcome to the Foojay podcast, all your news about OpenJDK.
Every 6 months we get a new version of Java. Java 26 is just around the corner and will be released soon. But most companies stick to LTS long-term support versions, which are maintained and receive security updates for many more years. Versions 8, 11, 17, 21 and 25 are such LTS versions. I hope most of your systems are already on one of the latest versions and you're not stuck on 8 or even earlier. As a reminder, 8 was released in 2014, so much has changed since then. If you're doubting moving from 21 to 25 or even from an earlier version to the latest LTS, this podcast is for you. I invited one guest for this episode and have a few quotes for interviews recorded at conferences last year to guide you through the most important changes between release 21 and 25. Jakob, this podcast was actually your idea, so thanks a lot. Can you please introduce yourself?
Yeah, my name is Jakob Jenkov. I am a Java developer since 1999. I've had some years in cloud architecture as well, but at the moment I am back to doing architecture and Java development again. But of course, all products today have some kind of cloud aspect to it. So yeah, I haven't let go of the cloud part. We're just now I'm doing more product development, but it's with Java. And we have actually just recently started migrating to Java 25 at work. So that's interesting. I think it's not out everywhere yet. Maybe by the time this is published, maybe it is, but yeah. So it's a process.
You're working on it. Okay.
Exactly. I've been, and that's how we met. I've been writing a lot about Java, and just as you have. And I think that's how we met originally. And
your tutorials is one of the biggest thing you can find online with tutorials related to Java, Java Vix, but also related technologies. So I cannot remember, but the number of visitors you have on your tutorials is huge.
Yeah, it was, but as
AI.
AI eats everything, right? It also it ate Stack Overflow, but it has also been eating away from my side.
But I'm sure that a lot of the knowledge in the models is based on your website as one source of truth about Java.
I have tried asking it for some of the topics that I know are only on my website, and they can answer those. So there is something coming from my website, right?
Yeah,
so.
And maybe one day you will get a big bag of money from these models. Because
I wish.
That was actually the discussion we had in the previous podcast, micropayments and an idea of how we could, how all these providers could give some of the benefits back to the people who provided the sources. But that's for people, please listen to the previous episode of the Foojay podcast and you can know more about that. Okay, let's start with all the changes. I have a quote from Jonathan Vila, I think recorded in Amsterdam last year, and it's about the overall bug fixes and performance improvements. Let us listen.
In the reality is that usually companies are far from those latest versions. So those new features are great, but companies are more, in the safe area. And, it takes a lot to migrate from one version to another. But definitely staying on the latest version will help on not only on the new features. There are a lot of bug fixes. Yeah. There are a lot of vulnerabilities that usually when we talk about a new feature, a new version of Java, we expect to find, shiny new things. But even if they don't publish any new shiny thing, they have fixed a lot of bugs and vulnerabilities. And it's important to check the OpenJDK issue track system and see how many bug fixes, vulnerabilities, even SDK or API new methods. Yeah. Not not always. Those new additions are published in the new in the release features published by the new version. But you need to find out, and you will find that there are lots of new APIs additions that can help.
Okay, so an important thing to remember here is it's not about all new features. There are a lot of improvements and bug fixes ongoing with each release. Is that something you see when going from 21 to 25, that you just win on performance improvements?
It's definitely. I don't know if you can, like, how much you can feel it, but the virtual machine is getting better all the time, right? And especially some of the hidden things that are like hidden a lot from us is the JVM's capability of compiling, to native code, and as part of that native code, use these SIMD instructions, these vector instructions. So vectorization, is it's sometimes called, of the code. And I don't have any insights on exactly how many changes were made of that, but they are typically people are getting, or like the people who are experts in this, they are getting better and better at figuring out how to take normal code and vectorize it.
Yeah, and because Java jar applications are actually backwards compatible, you can run an older jar on a newer runtime and benefit from these advantages.
Exactly. I mean, especially if you come from Java 8 and you go to Java 25, then for sure there has been added a lot of these kind of auto-vectorization improvements. So
yeah, it's 12 years. It's 12 years since Java 8, so exactly. A lot has happened there.
But I remember actually, just in this relation, I remember having the discussion on LinkedIn with someone who said that in their company, they would stick to Java 8 because it was the long-term support version that had the longest support into the future. Personally, I kind of find that to be like a non-issue, because if you might go on Java 17 and it has a shorter end of life, so for the support. But before you get to that, you will have, Java 21, and then you have Java 25. So you will always be able to switch to a newer LTS version, which has enough of a long-term support end of life, that you can get from that one to the next one, to the next one, to the next one, bridge it into the future. So, yeah, you should definitely try to stay up to date with the latest LTS versions, in my opinion.
And eventually, Java 8 support will end.
Exactly.
Okay.
And then you have no choice.
And then you have no choice, indeed. So that's the overall thing. And then there are a lot of improvements, and we're trying to focus on what changed between 21 and 25. First one, and there are quite a few posts about this, is that JavaScript, so Java as a scripting language, becomes more and more of a possibility and something you can do. Yeah. And I have a nice quote about that from Ryan Svihla.
Oh, it's the scripting stuff. Yeah, I mean, 21 was already a huge step up from the past, just being able to write a simple Java class file and then just run Java against it was already a fantastic change. But literally that I can write scripts effectively in Java, for me, is really going to be a game changer for just working with my environment. It's one less thing to install, one less programming language to worry about. And that's, for me, the biggest change.
Yeah, so using Java for simple scripts, like most people use Bash, Python scripts, but actually Java is also perfectly suitable to do such things. Huh?
That is true. I think it might be mostly true for Java developers who already have the SDK installed. If you are just a regular Linux user, maybe you won't have Java installed, but you will have Python installed. Maybe you want to stick to Python. But as a Java developer, you can definitely start using this scripting capability. From what I have seen, it has become a lot easier to write a simple script, run it without even compiling it. You just ask the JVM to run it, and it compiles it itself. You can even have like multi-file scripts, right? You can import other non-compiled files into your script, and also now in with the latest changes in Java 25. And actually, between 21 and 25, this is one of the things that has been proved a lot, that you can just write some very, very small script files, and and like you don't need a class declaration anymore. Yeah, you can declare even functions outside of a class, and you can still call them. And then behind the scenes, it gets inserted into a class, but you don't need to worry about that. So yeah, that has gotten a lot better. I haven't played too much around with it myself, but this is definitely something to think about.
Yeah, I love it because you have this compact source files and instance main methods. That was the JEP which was introduced in Java 25. So that's indeed the private static final main string array args has been simplified into public main, and that's it. So if you want to explain Java to a newbie, that's definitely much simpler. But I use it a lot, even in CI/CD, to do some stuff on the build pipeline, for instance, and compile something.
And that's what I was also thinking. Like if you're a Java company and you need to do some scripting in the CI/CD pipeline, instead of having to change to Python, it's really nice that you can now just stay within the language that you already have a lot of expertise in.
Yeah. The only thing we are missing is a bit that, like in Maven and Gradle projects, you can add your dependencies. That's not possible with pure Java yet, but still you have the gbang tool. I don't know if you've used that, but it's really... No. I use a lot of gbang in the Foojay examples, explaining Java on the Raspberry Pi and interacting with electronic components. There you have gbang that, in one file, you define your dependencies and then just your code to blink a LED, for instance. And you don't need a full main. And that's where we are arriving into a state that is very comparable to Python and these other scripting languages, where you can combine everything in one file. But as a Java developer, I really love this simplicity. Mary Grygleski also said something about this.
Definitely a lot more simpler to use too. And I think it's becoming very crucial, I think, in this modern age when we are now like faced with the other languages that are, purportedly, or also like it's true too, they are a bit, the interface is simpler, maybe for folks who are less of a programmer to use it. So I do see it that one aspect is very good if we can definitely simplify, you kind of take away some of the complexity of interfacing with it. And so becoming more attractive to, let's say, the data scientists. We're hoping they can also adopt it, and because there's just such powerful features within Java itself. So I think Java 25, we are getting back, I think definitely has make a lot of inroads into like making it easier and
to write code,
to get for people to get adapted to it. I think that should also be the way to go to, especially for the AI way things are going, vibe coding, all of these things. So a lot
of changes there.
A lot of changes, that's right,
Yeah, vibe coding, AI. We have a lot of that. LangChain for J, also something which brought AI to Java. So all this combined, I think we can indeed maybe win a few Python believers back to Java with what is now possible.
It's definitely possible. It's definitely possible. Sometimes people are not choosing tools based on what solves maybe the problem best, but what is easiest to use for them. And we can see that when a lot of people have chosen Python instead of maybe C++ or Java or C# or whatever. But I think this is a realization within the Java camp that ease of use is a big driver of adoption of a language. And these scripting features are simply making Java a lot easier to use. So it's much easier to just play around with it. Just install Java, write a couple of scripts, see something happening. And I think especially that is my impression, that this is often the kind of interaction that data scientists have with data. It's not always that they're writing a complete program and just reusing that program again and again and again. Sometimes they are doing like one-off projects, like trying to get some data from this system, from that system, and try to make a report for management, and they hand it off. Maybe they never have to do that report again. So that kind of more exploratory data science will now be easier to do. Maybe not easier than in Python, but at least maybe we're getting close to as easy to do in Java as in Python.
Yeah, right. And that you don't need full projects to do that. Yeah.
Exactly, and it also maybe makes it easier for those of us who come with a Java background to get into the data science tasks, right, or the projects or whatever, because now we don't have to learn a completely new language and a complete new environment. We can kind of stay within the environment that we already know. And now we can, it opens up for us.
Yeah, and tries new stuff. Okay, scripting is on one side, it's very visual. Another topic, which is inside the GVM, is the garbage collectors. Before I joined Azul and learned about all these different garbage collectors and the different use cases, as a Java developer, I never worried about it. It just happened, garbage collection, and that's the nice thing about Java. You don't need to be a GVM expert to use Java fully, but as soon as you realize that this is a very interesting topic, and you see that there is a lot of evolutions ongoing in OpenJDK with these garbage collectors, like between 21 and 25, we had the generational Shenandoah. Can you explain both words? So Shenandoah is a garbage collector?
I'm not completely 100% into all the details about the different garbage collectors, because there are several, right? We have the is it the set or the C1, which is like Oracle's official. I think it's Oracle's official concurrent garbage collector, and I think Shenandoah is becoming the OpenJDK's version of that, or like alternative to set 1 or C1. And basically, as far as I understand, is like with the concurrent garbage collectors, is that before they had to kind of, or like earlier, they had to kind of stop the world and then garbage collect, and then they could start the world again. And that means stopping the world means stopping your program. Yeah. Now what they can do is they stop your program for a short while. They do a little bit of marking or a little bit of internal bookkeeping. Then they can start in the background a concurrent garbage collection process, which is then figuring out in the background what needs to be garbage collected. And when it's ready, it can stop. I think it can stop your program again for a little while, clean up, and then your program continues running. So a lot of the garbage collection that before would take execution time from your program is now happening, or can happen in the background when you're using these concurrent garbage collectors. Yeah.
And the generational is that the
that's
objects
a different concept.
The objects which are in memory. What is it that most objects die very young? So those are variables within a method. So they're only used within that method, so they can be cleaned up very easily. And the generational memory is then objects which are kept in your application for a longer time, and they move through different spaces of the garbage of the memory space. But my colleague Gerrit de Groenewald, he has done some amazing talks about all these different. I will add a link to the show notes of this podcast. But indeed, you have all these different garbage collectors. You have then specific ones, like Azul has also the C4 garbage collector in Zing runtime. It's an amazing piece of technology. And it's indeed, as a Java developer, you don't need to care. It just happens. And the defaults will make sure that your application runs as smooth as possible with the shortest amount of time for stop the world pauses, if they are needed even. There are even use cases that you don't care if you're processing a batch file in the background. Again, with a script, for instance. It just needs to run for one time. You don't mind if it stops for 2 seconds. Then you can pick another garbage collector, which makes your application run faster, but has these stop the world pauses, but you don't mind. It's unbelievable what happens under the hoods of GVM.
Yeah, there is really a lot going on, and you're right that there is a little performance penalty for using a concurrent garbage collector, but what you're getting instead is a lot lower maximum latency, right? Like your garbage collection pauses are never going to be very long. But maybe your throughput might be slightly lower. But you say, it depends on the situation. Sometimes that's fine. Sometimes it's not. And you, like you say, if you are doing batch processing, you can choose the old garbage collector if you want.
Okay. Next topic. So you have these OpenJDK projects. So these are evolutions within OpenJDK which run over a longer time. And then from time to time, new features get introduced. So one of those projects is Project Loom. It's about virtual threads and structured concurrency. Let's start with a quote from Anton Aripov.
Loom is probably one of the most prominent or impactful updates in this that has happened in this period, because if let's say now we have this in platform, right? We have virtual threads in the platform, although the story is not complete without the structured concurrency and everything like this. But now with the recent improvements, if the framework like Spring incorporates this feature into the supported whatever mechanics framework, you get the improvement from the platform for free. Like the need for the other tools, let's say like reactive frameworks or even Kotlin coroutines, even though they solve slightly different problem, is pushed further away. So you need it later, and actually you get a lot of improvements just for free. Of course, you need to stay up to date. You have to update the JDK, the framework, and so on. But I feel like naturally, it's less of a hassle than trying to solve it like with clutches and libraries and everything like that. Yeah. So I think Loom is one of those that is very interesting. There's a lot of interesting updates in the platform in the upcoming releases, or something that is a work in progress, like Valhalla. The outcomes of Valhalla, it has been a long project, but now suddenly, because of Valhalla, null safety is also coming. At least on the let's say it's in the air. It's in the air somewhere. So null safety is an important feature of Kotlin. Of course, probably the single most important feature there is. And now if we have that in Java, it's also like a huge improvement for the platform. There are some like small other updates. I'm not so like keen on records and everything that is related to the pattern matching. Nice syntactic feature. Definitely needed for data-oriented programming, as we call it right now. But this is not a huge game changer in my mind. Like when I'm thinking about the platform and what the platform can enable in the future, like with the recent changes around AI, ML, these kind of things.
Yeah, Anton mentions a lot here. Project Valhalla is for one of the next versions. We'll see when that arrives. But the main topic here was the virtual threads. Did this change a lot of how you implement code or develop architectures?
Most of the time, when we develop like services or like big applications, the threading is handled by a platform such as Spring Boot, or in our case, we are using Apache Pecco, which is a fork of Akka, the Scala platform, with the actor model. So a lot of the threading is handled behind the scenes by those platforms. However, we do have some level of compute that is happening within the application, and where we have to manage threads ourselves, or where we do manage threads ourselves, because we need to, or we want to parallelize the workloads. And I think virtual threads, they don't really change much if you're if what you are doing in these workloads is mostly compute. But as soon as you start doing I/O, such as calls to REST services or databases, sending messages to like an external message broker, all these kind of things, then virtual threads starts really helping a lot because we can use the CPU resources a lot more efficiently that way. And also they don't take up as much memory per thread, so we can allow ourselves to use a lot of them.
Again, we don't need to care about it because it's not the GVM who manages it, but the framework that you're using. So if you're a Spring user, a lot of cases it falls back to these virtual threads where they are applicable, and it's managed by the framework, but you just see that because this happens, your application can handle more load, can handle more messages, responds faster. So again, you're benefiting from running on a newer version of the runtime and a new version of the framework. You have to upgrade. That's for sure.
Definitely. And also I am working a little bit on a hobby project from time to time. And in one of those parts, I need to do some, to implement some servers. It won't be using HTTP, so it will be using some other protocol. That's why I'm doing it myself, or hand implementing it. And I just did some experimentation with the virtual threads, and I realized that I can probably implement this whole system, like the server part, much, much simpler with virtual threads than trying to do it in I/O. I think I can use virtual threads and blocking I/O, and instead of using in I/O, which is a lot more complicated to handle. There are a lot more details you need to handle yourself in I/O before your server becomes stable and robust. So a part of that project Loom includes virtual threads and structured concurrency, and structured concurrency is about enabling you to more easily express like a computation graph that can be parallelized. So like you say, I want to start here with this little operation, then I want to fork that into 3 operations. When these 2 are finished, I want to start another one, and when this one down here is finished and this one over here is finished, then I want to finish with something else here. This kind of parallelizable and dependent graph of little jobs to execute, I think is what structured concurrency is supposed to help you make easier to express, right? Because if you have to write this today with futures and like callable, completable futures and these kind of things, it gets a little bit messy. But I mean, you can do it, of course, but it can probably get a little bit more elegant.
Yeah, it also want to help you if one of these tasks in between fails, that you can immediately stop the others and say, I cannot finish this job because so the whole graph cannot be completed because one of the node or one of the tasks in the graph has failed. That's a good point. And this structured concurrency, it was JEP 505 in Java 25, I had to look it up. And it is in the 5th preview. So again, it means if you really need this, if you have a use case for this, you can use it. It's a preview feature. That means you have to enable preview features and have a bit of a risk that the API can still change before it becomes a finalized version or a finalized API, but it is there. So you can use it. Because it's a preview feature, that also means it is inside OpenJDK, it is well tested, it is documented, it is actually ready to be used, but they didn't finalize it yet because they're waiting for feedback from the community. Is this actually what you need? So people who have a use case like this, please try it out, correct?
Yeah, exactly. And people who are doing especially heavy calculations, like sometimes like in the pension industry, we have to calculate such a prognosis or what you call like a projection into the future, like how much money will you approximately have when you retire. These can be very heavy calculations, and the laws have changed recently, so you have to calculate maybe 10 different scenarios. So I mean, in these cases, you really want to kind of parallelize these kinds of calculations and take advantage of every bit of computing resource you have available in the computer, right? So
I can imagine everyone working in tax calculations can also benefit from this.
Yeah, exactly. It's the same kind of thing, right?
If I think of, I live in Belgium, if I think of all the Belgian rules and corner cases, I think you will have a lot of structured concurrency there. It's one of those nice things coming to OpenJDK. On Foojay, we have a podcast with every new release. So 26 will soon be announced and will then handle all the changes in 26. So people who want to know what changed from version to version can also look back into the previous Foojay podcasts. People sometimes say that Java doesn't evolve fast enough. Maybe they're right, I don't know. What you see is if something gets introduced like virtual threads, that it's very stable, well thought out, and because there were several incubator preview features that people could already try out in earlier versions, it's also based on feedback from actual users. This is what we want, what we need, or can you maybe change this, and then sometimes it happens in the next version. So that's also why I love how Java evolves.
With a new 6-month release cadence, or it's not so new anymore, but like once they switch to the 6-month release cadence, Java feels a lot more alive, right? We are getting, maybe we're not getting 10,000 new features per release, but we are getting new releases and we know exactly when we get them. It's a lot more predictable. Something is coming, it's coming soon. Every 2 years, we need to plan. Actually, in the beginning, it was every 3 years with the long-term support versions, right? But now it's every 2 years. You kind of know already, kind of need to plan around that. In 2 years, new LTS, we need to look at what has come in and see if some of it is something we can use. And if not, we still upgrade because we still get all the security fixes, the performance and stability fixes as well, right?
Yeah. Maybe we need to remind. So I mentioned Java 26 is coming in a few weeks, months. That's a short-term version. So that means it will only be maintained for 6 months, but then we have 27, and then we have to wait for, 29 will be the next LTS, I think. So then we can jump
29,
to the next one. You have all these changes in between, and normally companies are advised to stick to the LTSs unless they really want a feature which appears in one of those short-term releases. Like I know that the vector is one thing that people are waiting for, vector improvements. We'll see when that arrives, and maybe they have to then switch to an STS version. Okay, a next topic is Project Leyden. I don't have a quote about that, but it's Project Leyden is about can we improve the GVM to start faster, use less memory. I think that's also a part of it. But what we've seen in Java 21 to 25 is that there were improvements for ahead of time. Can you explain a bit what's happening there?
It's all about startup time. Like you want the JVM to start up fast, and the reason you want that is, for instance, if you want to use Java for serverless services, you want them, the time from a request arrives at your service, your serverless service, the time it takes to start up your service and activate it and execute the request and process it and send a response back. You want that startup time to be as short as possible. And sometimes if you have a very large application, just loading all the classes can take a lot of time. Well, there are several things they're trying to do in this area. So one of them is to, I know that AWS has their own take on this.
Snapstart. I think that Snapstart is the name.
It's Snapstart. Exactly, that's the name, Snapstart. Yeah. But basically what they're doing is they start up the application, they figure out everything that is in memory at the time. They take a snapshot of that, they break that up into a lot of small parts, and then they write that out to a lot of different disks so that when a request arrives, they can load all these different parts from all these different disks in parallel, very fast into memory. You assemble your application again and send the request to it. So this is what AWS is doing, but I think as far as I remember, Azul has something similar, right?
Yeah, Azul has Ready Now, and it's a bit similar. Ready Now already exists for a long time. You create a file during runtime with every decision of the compiler. Yeah. Why did I compile this method into this native code? And when you restart it, you can read that file again. We also have Crack. That's again
Crack,
a project with OpenJDK. Crack
Yeah.
is another thing. I think it was the snap starting was even based a bit on Crack. Is that you dump the state of the program like you just dump the state of your system when you do put it to sleep, and then just restart from memory. It's nice to see that projects within companies like Azul, but also in open source, influence how OpenJDK evolves.
Exactly, yeah.
The things that have been proven in the field as this is something which is actually needed in OpenJDK, it's not there. Let's now bring it to OpenJDK, and this project Leyden and ahead of time is one of the ideas is that during your build time, you actually run your application, and then some decisions on which classes need to be loaded is stored within the jar file so that it can use this info to start up faster. So it already knows, I need to do this and this and this, or it has already been done. It's an ongoing project, and it's all influenced by the cloud. Like you say, if you have a scaling system, you want your new scaled services to start as fast as possible. And this is something new if you compare it to the history of Java.
Yeah.
Java started almost 30 years ago, so it's cloud didn't exist. Like AI didn't exist 2 years ago. Serverless
definitely didn't exist at that time, right? So.
And it's nice to see that all these other types of how you use applications or run your application, deploy them, are now reflected in how the OpenJDK evolves.
Yeah, and I think maybe we can even benefit from these faster startup times when we are doing scripting, right? Mm-hmm. Because then the JVM is just very fast at compiling and running your application, or like your tiny little script, right? Instead of you having to wait for a 50 megabyte Java virtual machine to start up. But I mean, they start up pretty fast, but of course it can always get better, right? There's another thing, like with the ahead of time, like we're talking about here, these ahead of time features. Like one thing is the startup time, but the other thing is just getting faster to an optimized performance, right? Like normally when you start up an application in Java, it has to run for a certain amount of time before the hotspot, the JIT compiler has realized which parts of your application need to be optimized and which don't. This doesn't really work very well for serverless, because serverless starts up. It runs maybe one request, and who knows when the next request is coming. Mm-hmm. So in order to get the maximum performance out of that, they run the application, they run it for a while, they then write some profiling data down, and then that profiling data can also be used the next time the application starts up for the JVM to know immediately, okay, I need to optimize this and this and this, and this over here is not necessary, right? Yeah. So it can load it very fast.
That's again one of those stories I was not fully aware of as just being a Java developer for many years. Is again what happens with your Java code. The Java code that you write is not the thing that's being executed. There's the class file in between. So that's the bytecode. That's the first thing. And then, as you mentioned, when your application runs, you have these hotspots. This code has been executed 5,000 times. It's time to recompile it to native code because you're running on a Mac with an ARM processor, or because you're running in the cloud on Amazon or on a Graviton. Then this class file becomes this native code, which can do the same thing, but a lot better and faster. Yeah. And that's, again, one of those, who invented this? Who created this? Who maintains this? There are so many different... I run here on... I have a Mac, I have a Windows, I have a Linux, I have Raspberry Pis with different types of processors. I now have RISC-V, which is new type of processor. And again, Java runs. So who are all these people making this?
Probably some of the people who are also doing all these LLVM cross architecture compilation tools, right? So, but it's very interesting, and one of the things that is coming a little bit in the future is the project Babylon, who with Juan Fumero is part of that team from Tornado VM. And that's one of the projects I'm really looking forward to, because that's when we can get Java code to run both on all of the CPUs that you have in your machine. Of course, we can already do that with threads, but then they can also run it on, the onboard GPU. And if you have an external GPU, like many laptops, they have both the onboard GPU and an external GPU. It can run on the external GPU. And probably, who knows, maybe in the future also on FPGAs like Tornado VM can. But this is really going to make Java a completely different beast, right?
And then again, so Project Babylon, I don't know how long it's going on. I think it's already 8 years. Tornado VM, also an old project. It has maturity. And then you see now, suddenly they become very relevant because we have all this AI, model training, a lot of calculations. KPUs are very good in calculations. So we should really offload some of our methods, functionality, things which are happening in our application are better handled on this kind of architectures, on this kind of systems. And it's really nice to see that Babylon and Tornado VM really fit in that spot.
Yeah, it does. And I think there's another thing that I've been thinking about. And that is sometimes, when we deploy services to the cloud, we're deploying in an instance that only has like 2 virtual cores and no GPU. So in that kind of setting, we are not actually getting that much out of all the new Java features, because you can parallelize all you want, but if you only have 2 cores, it's not gonna help very much. Right. But a lot of our personal computers, they now also come with a lot of cores. They come with iGPUs, they come with NPUs, they come with sometimes 2 graphics cards, right? Like they have both the internal and the external card. And when you look at it like that, and you see that Java is now becoming more and more able to use that, I have a feeling that Java on the desktop is getting a lot more interesting than it has been for a lot of years, especially combined with something like JavaFX that is already using some level of GPU or hardware acceleration in the background for generating the UI. So in the cloud, you can kind of decide exactly which resources you have. So maybe you don't need to have, maybe you don't benefit so much from the Java VM automatically realizing what you have in your system and using it. But on a personal computer, that's a completely different game, right? You run something on a big laptop, you take the same program, you run it on a small SBC, like Raspberry Pi or whatever. And the Java VM will, in the future, be able to just kind of use everything in your chips, right? In your chipset. And not just the CPU. And I think that's very, very exciting to see where that lands.
But we have to be honest, it's not in 25. So people are on Java 25. So maybe
this is for the future.
Maybe when we repeat this podcast in 2 years and we are talking about 29, maybe we will have some of these in there. But there are things ongoing, and if you want to try them out, you can either already try Tornado VM, or I'm not sure about Project Babylon, if there are many preview features in Java 25 already, but they will surely come.
Maybe you can get Juan back on the podcast one time and see if he's allowed to talk about it. Yeah.
But I interviewed the Tornado VM team at Devox. They are in one of the earlier podcasts, so I will add the link again in the show notes. I don't have a quote now, but a longer interview with them is available. Yeah. Okay, next point is the class file API, and I have a quote from Ronald de Huizer, and I was also at Devox.
I'm going to say something that nobody probably mentioned before, but for us, it's going to be, and I don't know whether it's already in 25. I think it is, to be honest, but it's the chap where ESM, the library for bytecode reading, is now natively part of the GDK, in fact. So it would mean that where in the past we had a dependency on ESM to find out what is going on exactly, when you pass us a Lambda that needs to be scheduled, we could now use it, do it with standard Java 25.
Are there a lot of changes in that topic within Java? Is how you can read class files and other files related to the program itself?
I think that's the biggest that I know of, and it's huge because beforehand we always had to use ESM, which is a great library, but which showed its age also, and to have like a nice built-in way in the JDK itself is really cool.
Roland is the creator of Job Runner, so that's a library to schedule jobs, and he really needs to be able to look into class files and load class files when he needs them. And again, he mentions something which you already said before. He was using a library which can now be replaced by a feature which is in OpenJDK, which is in the JVM, which is in the Java language, so the class file API. Is that something you use that you know, or that you can take advantage of?
Not immediately, but I mean, both at work we have our own programming language, or the company has its own programming language that is implemented and interpreted in Java, and it's usually something that that is loaded at runtime, at startup time. And then it is turned into like an object graph that can then be executed. But if we at some point need more performance, it would be a possibility then to take this dynamically interpreted object graph and turn it into a Java class, which then can run faster, right? So that's definitely something that we might be able to use where I work. It's not the area that I'm sitting in, but I know the guys who are working on it, and we have talked a little bit about that possibility. It's probably not something we're going to do in the near future, but it's a possibility. It's definitely a possibility.
And is there to use that?
And definitely. And I'm also like in one of the my little projects at home, I am also implementing a little programming language, and this is also something that is intended to be like interpreted, but if you define a function and you expect to be calling it a lot of times, then maybe it would make sense to, compile that function into a complete Java class so it runs faster. But we'll see. I think it's definitely for like these kind of use cases where you have something that is kind of dynamic and you have your application which is more static once it runs, and you want to combine them. So you want to put the dynamic stuff into your application when the application starts up, but you don't want this to run slow just because it's being interpreted. Then you can compile it into classes at runtime, and then you can gain the speed. I think that makes a lot of sense, and I think there are plenty of use cases out there that we just maybe haven't thought about yet. But I mean, the people who are already using these ASM and all these kind of older toolkits, they already know what their use cases are. So there are plenty of people who already need this, right?
I think it's also a big part of what Spring is doing. Spring Boot, loading classes at runtime and configurations and stuff like that. So again, it will be handled by the framework. The frameworks get improved. They run faster. They start faster. So everything is actually connected.
And there were some of the early of these ORM frameworks that used the bytecode manipulation as well, right? So they were also like looking at a configuration of a class, and then or like a table, and then from that at runtime generating some classes and making changes to the class files. And such tools could probably also benefit from this kind of library.
Related to bytecode, that's one of those other hot topics that I never cared about as the Java developer, is actually how much info is in a jar file in bytecode. And I had a wonderful conversation with Matt Coyley, who developed Recaf. And Recaf is a tool to look into bytecode. And again, we'll add a link to the show notes. He explained to me what you can find in bytecode. And what I didn't expect from that interview is that he also showed me how you can be misled with what's inside the jar file. So he executes a jar file which writes hello world, and if you look into the sources, there's something completely different. So how you can... He's on the side of preventing hacks and what can be inside the jar file and how people can abuse it or misuse it. It's actually very fascinating, the whole bytecode history and what's inside a jar file. So again, something interesting for people who want to know more. One of you have a lot of pet projects. Mine is Java on Raspberry Pi and the Foojay library. I didn't implement it myself, but we are working on a version 4, hoping to release it soon, which is completely based on the foreign function and memory API. This is something arrived in Java 22, so between 21 and 25. So it's a way to replace JNI, which was inside Java since 1.1, one of the very first versions. Very complex to use. And now we have FFM. I've talked about it at a few conferences. It makes it a lot easier to interact from Java directly with memory, so outside of the garbage collector, and with native libraries. Do you see use cases in what you are doing there?
Most of what we are doing is staying within the Java virtual machine. But I can imagine that this is very useful for, like, if you want to use like AI libraries or something like that are implemented in C++, and you want to use them or call them from inside of your Java applications.
I like that you again mentioned the AI, because again this FFM, so it started in Java 14, so AI was not in the picture really. And again, you see that something which is now recently finished perfectly matches with, I want to use in an easier way libraries which were written for AI, LLM processing, text processing. On the Raspberry Pi, it's just to interact with the GPIOs and toggle some LEDs and more complex stuff. But there are really a lot of use cases in the AI space, for instance.
Yeah, in the AI space. And I also think, like for other things that are normally more CPU heavy, such as, let's say, compression and decompression, or encryption and encryption and decryption, maybe there's something to gain from using a library that is written in some native code, because after all, you're just asking it to take this data and give me, the decompressed or the decrypted code, and you don't need to interact much with it, but it just needs to do this big job, give me the result, and maybe these kinds of or like encoding and decoding of video and audio, maybe these kinds of use cases can then make your Java application faster. Because it's not only Java anymore, but
I interviewed someone who had a history in mathematics and was now working on accountancy financial products with Java. And he indeed mentioned, I know of this very good C library to do very complex calculations, not something I want to re-implement in Java because I know it's there, and now he can very easily call these functions with the FFM API. I spoke about this in the Java Champions Conference recently, so again, a show note I can add. I have in my presentation the most complex method to get the length of a string in Java is not by using Java string length, but by using a native library. It's just a fun way of showing how you can put a string directly in memory, then give that memory address to a native library and get the length of the string. It's 10 lines of code. It's much to get the length of a string, but it shows you how with a few lines of code you can directly put something in memory, give that location in memory to a completely different application, and get a result from that. And I really love how this is now possible with something which was introduced in Java 22. So people who are using this kind of functionality can benefit from it if they jump to 25.
Earlier, I kind of hinted that it was mostly for performance, but it's not. I mean, sometimes you don't have that API in Java at all. It only exists in another language, and in that case, you don't really have a choice, right? You need to use that API in that native in that native code. And I think in those cases it's really nice, that Java can then integrate with all these other languages. Just like in GraalVM, there's one of the things they are looking a lot at, right? But so it gives us the possibility of integrating with APIs that we don't have available in our own ecosystem. So it's very cool, I think.
Okay. I have one last quote, and that's Jonathan Ellis and Ryan Silva, and it's about the Vector API.
Oh man, so for Brock, we are a fairly straightforward, we're wrapping REST calls to LLMs, right? So it's not doing anything super computational or anything super native oriented. But my last project before Brock was building JVector, where we definitely took advantage of the SIMD support with the auto vectorization and the improved foreign function API. So I've definitely seen the advantages that brings. Not using them in Brock yet, but we may have some native code in our future.
Yeah, I think we have some batch jobs coming up pretty soon. So I would say any day now. So listen, I've used Graal quite a bit, and we actually heard it in one of the talks today, and I love the Graal project. But compile time for building a native thing can sometimes be a real pain point. So getting that out of the way and getting good enough startup times, I'm very excited about that.
To the JVM to run everything.
Yeah, no, I'm very excited about that.
So Brock is a tool related to AI. Not going to talk into details about that, but so they are really combining. So they talked about foreign function and memory API. They talked about GraalVM and ahead of time, and then the Vector API. It's not finished in Java 25. I think we are on the 12th incubator, Jep. But as he mentioned, in JVector, which is a vector database, they use that preview feature with the new Vector API because they really need it. So although it's not stable, it's stable. It's not finalized yet. So although it's not finalized yet, they decided we're going to use this preview feature because we really need it. This Vector API, again, hot topic, AI, machine learning, language models, they use a lot of vectors. Do you think this will be an important change in OpenJDK?
It's hard to say if the Vector API itself will be the version of vectorization that will win, because we also have Project Babylon, as we talked about earlier, coming in the future. But the idea of vectorization, meaning you can execute the same instruction on many different memory locations at the same time in a vector of data points. Yeah, that is something that is going to be, or is already, it's already used internally in the Java virtual machine through auto vectorization. But the fact that we can now do it ourselves explicitly means that we can squeeze more performance out of the CPUs that we have available, right? And most CPUs, they already have some level of these kind of SIMD or these vector instructions available within the CPUs as it is today. What remains to be seen is if vectorization or executing vector instructions on the CPUs will be able to compete with executing the same kind of logic on the GPU that comes, with your CPU. I'm thinking an iGPU or I think that we don't know yet. So maybe what happens in the future is that you prefer to just use the API that is in something like Tornado VM or Tornado VM or like in Project Babylon, and then it will take care of vector, running or compiling it to the vector instructions of your CPU or your GPU or whatever. So this whole space is definitely very, very interesting. And the fact that we get the instructions available for us in the Vector API is a big step forward, because I've seen also, not in Java, but I know in I think it is in C, they have a JSON parser which is using these vector SIMD instructions, and the performance is 2-3 times faster than just using normal CPU instructions. So there is something to be gained from this in probably in more use cases than we know of. And once we get the API and it's available for us, we will start playing with it, and we will start realizing how to write algorithms for these kinds of instructions, right?
And the fact that the Vector API is already in preview for such a long time is, as we mentioned before, they new features don't get introduced in Java just because someone wants to have them. They get introduced when they are stable, when they are well thought of, when they solve a problem which existed, but also can fix a problem which is being worked on. And I think that's the main thing with the Vector API. They want to use it for some other improvements. And as long as they are not finalized, they're not going to finalize the Vector API. So again, the architects of OpenJDK are really the persons looking after the whole thing.
Yeah.
Are we evolving in the right direction?
Yes. And I think they even removed a feature recently, right? I think was it string templates that was introduced?
Yeah.
It was introduced in kind of a
also in a preview, I think.
And then it was taken out again because something in it was not working as they wanted it to work. So they said, okay, this is not the way to do it. So they took it out again, and use preview features at your own peril, right?
At your own risk, yeah. But I can imagine, like the Vector API, we have 12 preview features or 13. I cannot even remember. They're not going to remove it.
No. I mean, we know we want this API in there, right? So like if you take a step back and you look at the big themes of where the JVM is going, it's definitely parallelization, right? So both on the CPUs, but also on the GPUs at instruction level, at CPU core level, and also at GPU level. So we want these things in there. This is not just not just something that is nice to have.
Yeah. And you really link them together. So you have Project Leyden, Babylon, the Vector API, it's in Project Panama. So they are all different projects, but they are all inside OpenJDK. They are all related.
Yeah.
And one cannot exist without the other.
No, and it's all related to getting the Java virtual machine to be execute your code faster. Start up faster. Profiling and get to a well-compiled version faster, use auto-vectorization, enable you to use vectorization yourself, and
the fastest garbage and the garbage collection as fast as possible.
Exactly, yes, and with the FFM APIs, like the foreign functional memory APIs, like being able to call out to something that is faster than Java can do when you need it. So
getting to the fastest executed code possible in every use case, in every environment, even because we have cloud, we have desktop, we have embedded. Being able to run on all these environments is really a critical thing.
And Java is probably not so big on the desktop at the moment, but that's kind of where Java started, and I kind of have a feeling that it can run well on the desktop these days, right? At least the things that I'm starting up on the desktop, they actually feel very snappy. It's not like the old Swing kind of laggy UIs from like 15 years ago, right? It feels like a native app. I mean, it doesn't look like a native app exactly, but it definitely feels like it most of the time now. So.
And with JavaFX, you can style it in whatever you want.
Exactly. You can, styling is your choice, right?
I want to thank you for your time and your insights in what has happened between 21 and 25, and being my guest again in the podcast.
Yeah, it was a pleasure. Thank you for allowing me on again.
Pleasure was all mine. Thank you, and hope to see you in one of the next podcasts. To you, my listeners, also thank you for listening. Please subscribe to Foojay on social media, on YouTube, in Spotify, wherever that you listen or watch this podcast, and follow us on foojay.io for more news and changes related to OpenJDK and the Java world. Thanks for listening.
Give me a foo, give me a J, give me the friends of OpenJDK.